Hello everyone. Today I would like to discuss proper and improper fractions. Let's look at what I have written on the board. Consider a fraction m over n where m and n are whole numbers and the denominator n is not equal to 0. M over n is called a proper fraction if m is strictly less than n. So in other words, if you have a fraction and you notice that the numerator is smaller, strictly smaller than the denominator, such a fraction is sometimes referred to as a proper fraction. And m over n is called an improper fraction if m is greater than or equal to n. So this sign is read as greater than or equal to n. So what this is saying is, in a given fraction, if you notice the following relationship between the numerator and denominator, which is that the numerator is exactly equal to the denominator, or perhaps the numerator is greater than the denominator, then in that case we call that fraction an improper fraction. Given any fraction, notice only these two situations can occur. Namely, the numerator is strictly less than the denominator, so that means the fraction is a proper fraction, or the numerator is either equal to or greater than the denominator, in which case such a fraction would be called an improper fraction. Let's look at some examples now. So by the definition I've just given you, you'll agree that 5 over 6 is a proper fraction since 5 is less than 6. And similarly, 6 over 6 and 15 over 6 are improper fractions because in this case the numerator is exactly same as the denominator. In this case the numerator is greater than the denominator. So these two are improper fractions. So if we were to plot these fractions, well, let's look at 5/6 first. 5/6 is 5 copies of 1/6, and you'll recall from a previous work that if you were to divide the unit segment into 6 equal pieces, then the point at the first tick mark is 1/6, and then the second tick mark is 2/6, and so on. And we know that 1 is same as 6/6, so 5/6 would be to the left of 1. So a 5/6 is a specific point somewhere in this black area. And using that same logic, you can see that in fact for any proper fraction would be some specific point in this black region. And in contrast, if you were to look at 6 over 6, the improper fraction 6 over 6, well, 6 over 6, as we just went over, is exactly 1. And so in fact you can generalize and observe that any time you look at a fraction whose numerator and denominator are exactly the same, then you're really looking at the number 1. So that's what I have here. N over n, where n is any non-zero whole number, is in fact exactly 1. And n over n would be an improper fraction. How about 15 over 6? 15 over 6 is 15 copies of 1/6. And we already said 6 over 6 or 6 copies of 1/6 is 1. So 15 over 6 would be to the right of 1. And so 15 over 6 is some specific point in this red area. Using this logic, you can see any improper fraction that you try to plot would be a specific point in this red region. This would also be a good time to remind you there are points on the number line that are not fractions at all. So while it's correct to say any proper fraction is a specific point in this black region, we should remember that not to say a point here is a proper fraction, because in fact a point here may be a proper fraction, or it may not be a fraction at all. There are some points that are not fractions out here. Similarly out here, if you look at any red point, it's either an improper fraction or it's not at all a fraction. Here's an easy question for you. I have 3 fractions written out. Could you label each of them as either a proper fraction or an improper fraction? I think you can do that.